This module provides an overview of the deemed to satisfy solution for mid-rise timber buildings. In this presentation, we will cover a summary of NCC changes and controls, an overview of the different control elements, automatic sprinklers, fire-resistant timber, non-combustible insulation, and cavity barriers. We will also look at the use of the requirements in mixed-class buildings, and finally the requirements around the evidence of suitability or tested systems. There have been 6 changes or amendments to clauses in the National Construction Code to allow for inclusion of mid-rise timber construction. In summary, the main control requirements are as follows. The building or building part is Class 2, 3 or 5. The building has an effective height of not more than 25 metres, approximately 8 stories, and sprinkler systems to specification E1.5. Fire protected timber to specifications A1.1, non-combustible insulation, and cavity barriers to specification C1.13. The first level of fire protection comes through the use of automatic sprinkler suppression systems, whose function is to suppress a fire before the timber structure is threatened. It is widely known and accepted that sprinkler systems greatly reduce the fire risk to building occupants, their property, and to firefighters if they need to attend a fire event. Automatic sprinkler suppression systems have a very high success rate. Historic records and statistics over more than 100 years have shown that automatic fire sprinklers have been the most reliable fire protection system, with most estimates placing reliability above 90%. They are particularly effective because of their high reliability combined with early automatic suppression of fires without any human involvement. A study by Brands suggested that sprinkler reliability may range from 95 to 98%. The higher value also reported being supported by the US National Sprinkler Association. The second level of fire protection involves the provision of fire-protected timber. This is achieved by encapsulating the timber using fire-grade plasterboard. This means that in the very low probability event that the sprinklers might fail to activate, that the structural timber members are prevented or delayed from ignition during the growth period of a fire and prior to the fire brigade intervention. Encapsulating the timber members in fire-grade plasterboard provides a response to the enclosure fire similar to those types of members made from non-combustible elements, such as masonry or concrete. Typically for general timber or lightweight timber frame construction, a high level of protection to the timber is required. The DTS provisions require the use of 2 layers of 13mm fire-grade plasterboard for walls and 2 layers of 16mm fire-grade plasterboard for ceilings. For massive timber, such as LVL or CLT, with a minimum of 75mm thickness, a lower level of protection is required. As these are proprietary products, details of specific fire protective covering requirements should be provided by the manufacturer. But in general, this will typically involve 1 layer of 16mm fire-grade plasterboard for both walls and/or ceiling elements. For the third level of fire protection, the DTS provisions also require the use of cavity barriers to prevent uncontrolled spread of flame or smoke through cavities in the low probability event of either failure of protective covering or fire starting within the cavity. Finally, if insulation is used within a wall, floor or roof cavity for improving acoustic or thermal performance, then this insulation must also be non-combustible. So in summary, if the building or building part is Class 2, 3 or 5, the building has an effective height of not more than 25 metres and utilises fire-protected timber, automatic sprinkler systems, non-combustible insulation and cavity barriers if applicable, then it meets the deemed to satisfy solution for mid-rise timber buildings under the 2016 National Construction Code. This deemed to satisfy solution can also be applied to the Class 2, 3 and 5 parts of a mixed class building, provided the different classes are adequately fire separated and the entire building is protected by an automatic fire sprinkler system. This provides added flexibility for the design of new buildings and facilitating the recycling of existing buildings, as can be seen by the example in this illustration, where fire-protected apartments of Class 2 are being constructed above an existing concrete-framed retail area or car park. For mid-rise timber buildings of other building classes, the performance solution pathway or alternative solution has to be used. Some Class 2, 3 and 5 buildings are also likely to require a combination of both, a deemed to satisfy approach and an alternative solution to provide the most cost-effective outcome. There are a number of Wood Solutions technical design guides that are available from the Wood Solutions website, which provide guidance and assistance on these alternative solution approaches. The NCC also requires every part of the building to be constructed in an appropriate manner to achieve the performance requirements using materials and construction fit for the purposes for which they are intended. In most instances, for the materials and systems considered in this guide, the evidence of suitability for the fire resistance or resistance to the incipient spread of fire of an element of construction will be a report from a NADA-registered test laboratory presenting the information required by the NCC. Over its entire life, a building has a number of phases, from conception through design, construction, commissioning and use, maintenance, repair, renovation, and finally demolition. In terms of design and construction, a successful mid-rise timber building requires different building professionals to take clear responsibility in the key phases of the project. In terms of the design process, fire safety is only one of many design criteria that need to be satisfied. Other design criteria that need to be addressed include, amongst others, structural performance and robust design, acoustic performance, resistance to water penetration, resistance to termite attack, thermal performance, sustainability and functionality, aesthetics, and constructability. It is particularly important that the project team work closely together right from the start of the project and that they all understand the key critical factors required to successfully design and construct a mid-rise timber building. If they do so, then synergies can be exploited, conflicting requirements can be addressed practically, construction details simplified, and compliance can be more easily achieved and verified. As the construction of mid-rise timber buildings is likely to use a high proportion of off-site manufactured elements and systems, it is important to have the manufacturer of the prefabricated timber elements involved in the design process from the start. This will assist in achieving the most cost-effective and buildable solution. Whilst the different states and territories in Australia are responsible for local building regulation and oversight, and different requirements occur between these jurisdictions, it is still a common premise that the specific roles and responsibilities of the project team for any building need to be clear and agreed from the start. The importance of understanding clear roles and responsibilities has been a consistent and strong theme from stakeholders during the development of these new NCC mid-rise timber building provisions. The following provides some guidance on this matter, but the reality is for each project and key phase, a specific responsible person has to be clearly and unambiguously identified to ensure success. In terms of the overall design and documentation, this will generally involve a wide range of design team members and contractors with specialist skills, and generally the senior project architect is the person with overall responsibility. In terms of assessment and certification of the design and documentation, this will involve the responsible planning and regulatory departments, but the project building surveyor is generally ultimately responsible for signing off on compliance. During the construction phase, primary responsibility lies with the builder. This is arguably the most critical phase, as the building elements must be constructed as per the required design, to meet particularly the expected fire and acoustic performance requirements. Key elements such as fire-grade plasterboard and cavity barriers must be installed correctly, and it is the responsibility of the builder to ensure that these elements are installed correctly. Inspection of the construction works will fall to the responsible building surveyor, or perhaps the engineer, depending on the element being inspected. It is again paramount that all critical building construction elements be inspected to ensure compliance and signed off accordingly. With commissioning, which may happen progressively and then a final commission, this is the responsibility of the builder and the senior project team representative to ensure that the project is completed as per the design and functioning appropriately. The owner and/or building operator should also be involved with the final commissioning activities to ensure that they clearly understand how the building performs and the critical aspects of the building to ensure safety and health aspects continue to be maintained over the life of the building. So in summary, for mid-rise timber buildings, the new NCC provisions are relevant to Class 2, 3 and 5 buildings of effective height of not more than 25 metres, approximately 8 stories, protected by automatic fire suppression sprinkler systems, and utilising fire-protected timber in applications where the element is required to be of non-combustible construction, and cavity barriers to address the risk of fire spread via cavities, with all systems used required to be appropriately tested. Finally and critically, roles and responsibilities of the project team need to be clear and agreed from the start. For further information on wood and wood products, visit woodsolutions.com.au, the website for wood.